How can you intelligently control your energy flows within your household? So this is the question for our today's webinar, Intelligent Energy Control with our new Fronius inverter GEN24 Plus. I welcome you, ladies and gentlemen, to our today's Fronius webinar. My name is Michael Raunig, and together with my colleague Christoph Schierlinger, we will guide you through this webinar today. So if you have any questions during or after the webinar, please feel free to use our live chat function here in the webinar software and ask us these questions. Christoph will then answer all your questions during and after the webinar. So if you have any questions to the products or solutions, please feel free to use our chat function. Christoph and me, we are part of the team trainings and education in Fronius Solar Energy Department. And we are here for your trainings and webinars, and we give you an information overview about our Fronius solutions and products. So first of all, let's have a look on what's on the agenda for today's webinar. First of all, we will have a quick view about the Fronius GEN24 Plus device. So I will show you our new Fronius hybrid inverter, and we will go through, of course, the technical data of the GEN24 Plus device, and we will do some sector integration. So we will have a look on what sector integration and why it is so important for our new hybrid inverter. Second up, we will have a look on the compatible battery storage systems that are available for our Fronius GEN24 Plus device. Next up is then the Fronius multi-flow technology, and I will show you how the multi-flow technology works and why it is so important for optimal energy flow within a household system. Last but not least, we will have a look on the SPI index. So this is the system performance index, and we will have a look on efficiencies of the battery storage device and of course of the hybrid inverter itself. The second part of the webinar is then of course about the energy management solutions. So there I will show you how to do load management and how you can use the digital IOs of the system to seamlessly control your loads within the household. So this is then a possibility for you as an installer to deliver your customer an easy load management function and to switch on and off loads depending on the PV surplus energy that is available within the household. The last point for the day is then the installation and commissioning process of the hybrid inverter. So we will have a look on how to install the inverter very easily and how to do the commissioning of the inverter itself. Okay, so now let's start up with our new Fronius GEN24 Plus. It's uniquely versatile. So we have therefore made sure that we deliver a very seamless and easy device for you, first of all for installation, but also for commissioning, that you have a more easy way of installing and commissioning the inverter itself. Yeah, the Fronius GEN24 Plus is available in two different settings. So first of all, we have the Fronius Primo that will be available next year. This is a single phase inverter with power classes from 3 to 6 kilowatt of power. And we have the Fronius Symo. This is our 3-phase hybrid inverter with power classes from 6 up to 10 kilowatts of AC output power. So you see, depending on the system you are planning, you have the free choice on which power classes you are using, and depending on the country you are, you can choose between a single phase and a 3-phase inverter. Another very important step for the new hybrid inverter is, of course, that we now have 2 MPPT points. So in this case, you have 2 inputs for 2 different MPP trackers, and you have 1 battery input. So on this battery input, you can directly connect a DC coupled battery storage system. So for a direct current battery storage system, you have the possibility to feed in energy when you have surplus energy available, to store your electric energy coming from the PV system. And afterwards, you have the possibility to draw back energy in the nighttime hours, to draw this energy and to supply your household loads. Okay, and talking about energy sector integration, of course, energy sector integration is very important when it comes to our hybrid inverter. So first of all, the hybrid inverter fulfills the normal functionality of a PV inverter. You have your PV generator on the roof, and then you have your hybrid inverter in the basement, for example. And after that, of course, you can use this electric energy generated by the inverter to power up your consumer loads, so your loads within the household like lighting or television or the washing machine. But on the other hand, you don't want to only supply your electrical loads. You also want to supply other loads like the hot water generation, or for example, the cooling of the household with a climate system. And third, of course, you want to charge up your mobility. So for example, if you want to charge up an electric vehicle or electric bike, of course, you can do it with our load management of the Fronius inverter. So as you see, when it comes to our hybrid inverter, this sector integration is a very important topic. And of course, you can do a more economical system by including these three sectors: mobility, hot water, so heat, and of course, the electrical loads of the household. Therefore, you can do a big electrification in the household and save extra money by bringing in this PV surplus energy into good use, for example, load management, or for example, hot water generation. Okay, next up, we have the battery storage system. So with our hybrid inverter, of course, it is possible, as I said before, to build in a DC coupled battery storage system. And therefore, for the Fronius GEN24 Plus, we have the BYD Battery Box Premium available. So the BYD Battery Box Premium, the new system, has now two different variants available. First up, we have the HVS variant, and second, the HVM variant. So with the HVS variant, these small modules, they stand for a high load, so for a high capacity of load, but a lower capacity of energy. And if you want to use more energy, but less electric loads, then you can choose for the HVM variant, and the HVM variant has more specific energy, but has less compatibility of doing high loads, high power. So for both inverters, for the Primo and the Symo device, you will have the possibility to connect the BYD Battery Box Premium HVS or HVM system. So the HVS system is available in 5 pound 1 up to 10 pound 2 kilowatt hours of usable energy. And the HVM is available from 11 up to 22 pound 1 kilowatt hours of available energy. So depending on your needs, you can freely choose which system you use best to store your electric energy in the system and to withdraw it in the nighttime hours again. So depending on the needs of the household, you can freely choose between high energy or high power. So this is the main difference between HVS and HVM modules. The third compartment of this system is, of course, our Fronius smart meter that you see in the picture above beneath the inverter. And this Fronius smart meter is very important for detecting the energy flows in the system. So with the Fronius smart meter in the feed-in point, you have the possibility to draw data from the system, from the household, and therefore the hybrid inverter can decide when to feed in power into the battery system and when, for example, to supply the household loads with electric energy. So these three components are very, very important. So you have the inverter, you have the Fronius smart meter, then you have your BYD battery system. Next up is then, of course, our Fronius multi-flow technology. And the multi-flow technology comes into place when you want to achieve a very flexible system depending on your energy flows and when you want to use your energy at different loads and different components. So first of all, with our multi-flow technology, it is possible to use the hybrid inverter as a conventional PV inverter. So you have your PV generator on the roof, and you are using this DC power to convert it by the PV inverter and, for example, to supply your household loads or to feed in the energy into the grid. At the same time, and this is very special, you can put in energy into the DC coupled battery storage. So at the same time, you can power up your loads in the household, and if you have surplus energy, you can at the same time put the energy into the battery storage system. In the nighttime hours, when you need the energy, you can draw the energy from the battery back again and then power up your loads during the nighttime hours, and therefore avoid to draw energy from the public grid. The next possibility is to charge the battery system with energy from the public grid. So for example, when you have a cheap nighttime tariff or when you have flexible energy tariffs available, it can be a good choice to use public energy from the public grid and to charge up your battery system when the energy is cheap and available. So therefore, it is possible to charge up your battery with this charging from the public grid. The next very important thing is the so-called AC coupling of AC producers. So in this case, this would be the typical case of a backup solution. So for example, for retrofitting of an existing PV system, therefore you would use this AC coupling. So let's assume the customer has an existing PV system with PV generator and a PV inverter, and therefore wants to add up a GEN24 Plus to this system. So in this case, there is the possibility to do a retrofit and to bring in this new GEN24 Plus as an AC coupled device and to stay with the existing PV inverter. The special thing about the multi-flow technology is now that you can use these energy flows from the existing inverter, and the hybrid inverter will now use the AC energy coming from the existing inverter to use it, for example, to charge up the battery system. So with the help of the Fronius smart meter in the feed-in point, you always have the information on what energy is available and how many energy is available from the AC coupled producer. So in this case, it is no problem, for example, also if you don't have PV generator on the GEN24 Plus, to bring in an AC coupled inverter. So this would be the perfect case for retrofitting, for example, if the customer already has an existing PV system and therefore just want to add up a storage system, then you can just build in a GEN24 Plus device with a DC coupled battery storage system. And of course, if there is still space on the roof, you can also add up a PV generator for the GEN24 Plus and use both PV inverters for your system at all. So there you see you can use this multi-flow technology very seamlessly to just make sure that all your energy flows in the system are used and that you can charge your battery wherever the energy comes from. Second up is now the System Performance Index. And I want to introduce you the Storage Inspection 2020 from the HTW Berlin. So this was an investigation of energy storage systems. And fortunately, we won the energy storage inspection. So the energy storage inspection basically say that we have the highest efficiency with our Fronius and BYD battery storage system. And of course, this is very important when it comes to storage systems, because when you are buying a storage system and you want to store the electric energy produced during the day, of course, you want to make sure that you have the lowest possible losses in this system. Because if you feed in energy into the battery and then you withdraw it in the nighttime hours, you want to withdraw a maximum of this energy that you fed it in the daytime. So therefore, our System Performance Index of 94% is a very big topic, because therefore you can make sure that you have a minimal loss on the system and you can use your energy that you produce during the day also in the nighttime hours. Second thing is of course, inverter efficiency of 97.3%. So also here you're on a high side of efficiency, and therefore you can make sure with the Fronius and BYD system to always have the best efficiency available. If you want to gain more knowledge about the storage inspection, you can just access it by the HTW Berlin site, and there you find the storage inspection 2020, and there you have the PDF file that you can download for this inspection case. Okay, second part of the webinar is now the energy management solutions. So besides storing, we also want to, of course, manage our energy solutions. And therefore, it is first of all always very important to make an analysis of the consumption of a household. So before you do load management or storage solutions, you always want to know what is consumed in the household and to do an analysis on what's going on currently in the household. So data you need to know, for example, when is PV surplus energy available and when do the household draw energy from the public grid, for example. And when you know all this data, it is then possible to do, for example, the intelligent management of loads and of course the storage of surplus energy. So with the intelligent management of the loads, you can then, for example, control a PV electric charging station, or for example, a heat pump, or for example, also a climate control. If you then have energy left, you can always store this energy in form of a battery storage system, or of course, you can just generate hot water. As you know, water is a very cheap source of heat storage, and therefore, for example, with our Fronius Own Pilot, you have the possibility to store this surplus energy in form of hot water. So this is then the energy flow management. And for the energy management itself, we have our 4 digital outputs on the inverter. And these 4 digital outputs, they are integrated from start in the inverter and they are available for free. So whenever you buy a Fronius GEN24 Plus, you have these 4 digital outputs available in your device. And with the 4 digital outputs, it is possible, for example, to control an electric vehicle charging, to control loads like hot water generation, or for example, a heat pump. You can also control different loads like a pool pump. And of course, always very good idea for a PV system to control an air conditioning system with our 4 digital outputs. So depending on the load you have available, you can control it by our 4 digital outputs of the inverter. Depending the communication interface we have on our Fronius GEN24 Plus, the so-called pilot. This is then the communication interface that you have available on the inverter. And here you can see our 4 digital outputs. This is the orange plug on the right side, and there you see 4 different pilot signals. So this is IO0, IO1, IO2, and IO3. And these 4 outputs, they are 12-volt signals. So these are standard 12-volt DC signals, and these 12-volt signals you can use to power up, for example, a relay or a consumer directly. So depending on the load you are available, you can control this load by these 12-volt signals, and you can use the 12-volt signals, for example, for switching up a relay. So in this case, in this scheme, you see we have used the IO1, so one of these digital outputs, and we connected with a 12-volt signal to the 12-volt relay. So in this case, you are just using a normal standard relay, and you can switch the relay and therefore wire up the normal load path of the consumer of the load that you want to switch. So in this case, this is a single phase solution where you have the single phase load. And for example, you can also build in a manual switch where the customer can freely choose when to power up and power off the load that he wants to operate. So this would be the perfect example for electric car, or for example, for a pool pump. So here you can see this is a very easy setup. All you need basically is our Fronius inverter. Then you need a 12-volt relay. So this is a standard relay. And then of course you need your load that you want to operate. In this case, for our PV surplus control, you would need the Fronius GEN24 Plus inverter. You need the Fronius smart meter. The Fronius smart meter in this case is also very important for detecting the energy flows within the household. And then you need your standard 12-volt relay. So with the Fronius smart meter, you can now see what's going on currently in this system. So depending if you have a PV surplus energy available or you have drawn energy from the public grid, you have the data available from this Fronius smart meter in the feed-in point. So it is always important to set the Fronius smart meter directly into the feed-in point that you have available all the energy flows from the household. So what is now the use of such an energy management system with our digital IOs? For that, I have brought you an example of an electric vehicle charging system. And here you can see the customer, for example, comes home at about 4 o'clock in the afternoon and therefore connects his electric vehicle to his charging station. Of course, after that, he charges his electric car with the full power. So in this case, with 11 kilowatts of power, he is charging this electric vehicle. And therefore, under normal commuting profile, he would use around 60 kilometers of range. And therefore, when he comes home from work in the afternoon, he wants to recharge this 60 kilometers of energy. And therefore, of course, he is charging around a half an hour to get back these 60 kilometers of range. And what happens now is what you see in the left picture. Of course, you have a high peak, and this peak power is then drawn from the utility grid. And therefore, not much of the PV surplus energy is used to power up the electric car. And of course, a high demand is used from the public grid. And this is bad, of course, because first thing, you need to draw the energy from the grid, so you have to pay the energy from the grid. And second up is, of course, the peak load that you have with this system. And in the worst case, you have to pay the peak load to the utility grid, and we want to avoid this situation. So therefore, we have the second possibility with our Fronius inverter IOs, and therefore we have the possibility to first up reduce the charging power of the electric vehicle. So in this case, he is not longer charging with 11 kilowatts of power, but he is now charging with 3.6 kilowatts of power. And therefore, with this reduced power and with the control of the inverter, it is possible to charge over a longer period of time and therefore use more energy from the PV system. Of course, if there wasn't enough energy available during the daytime, there is the possibility of implementing a night charge. So therefore, you make sure that the electric vehicle is fully charged at the next day when the customer leaves his house. With this possibility of the intelligent energy control, you have the possibility to first up avoid a peak load from the utility grid, and of course to use your own PV energy for avoiding to draw energy from the public grid, and you don't have to pay the expensive energy from the public grid. And this is of course very beneficial for the economics of the system, because then you don't have to buy it, because you can use your cheap energy from the PV system. And second up, you avoid these peak loads coming from the utility grid. So for implementation and the activation of the inverter itself, we have available our Fronius Solar Start app. So you have the possibility now to download the Fronius Solar Start app from your app store on your mobile device, and therefore make the commissioning of the inverter with this Solar Start app. So you have then the possibility to do it via the Solar Start app, or of course via the browser. So in this case, we now want to implement the load management, and therefore you have the possibility to implement the load management directly in the first commissioning of the inverter, or of course you can also do the commissioning afterwards when you already have done the commissioning. So the next step is then to activate the load management in the settings of the inverter that you can see on the left picture. There you see load management, and you have your little button, and then you can activate the load management on the inverter. The second step is then the setting of the threshold limits. And these threshold limits, they tell the 12-volt signal when to activate and when to deactivate. So for every threshold limit, you have an operation mode, and then you can choose freely when to activate and when to deactivate the 12-volt signal. So when the 12-volt signal is activated, the load is operated, and when the 12-volt signal is deactivated again, then the load is deactivated and stops the operation. So depending on the load that you want to operate, you need to know, of course, first of all, the consumption of the device itself. So in our case, on the right-hand picture, we have now a device with 1,500 watts of electric energy. And therefore we set the feed-in limitation on 1,500 watts. So as soon as we have now a feed-in of 1.5 kilowatts, the 12-volt signal will activate itself. And second up, we set the threshold limits, and therefore we set the off threshold for a consumption of 1 kilowatt. So in this case, when we draw back energy from the grid, for example, or when there is a bigger load activated in the household, then the 12-volt signal is deactivated back again, and therefore a consumption value is rewarded. On the controlling modes, you can then choose between disabled, by power production, or by power surplus in case of feed-in limits. And of course, the case of feed-in limits you can only activate when you have a Fronius smart meter installed in the system. The Fronius smart meter data is then used for supplying these feed-in limits and the power surplus of the system. So then you can freely choose either to activate the 12-volt signal by power production of the inverter itself, or by a surplus power from the whole system. So on the up-hand side, you see now the controlling modes. You see the thresholds for the on threshold and off thresholds. So there you put in your feed-in or consumption limits. And third up, you can choose a duration signal. So with this duration signal, it is now possible to define different aspects for this energy management. So in this case, you have, first of all, the minimum duration per on signal. So this is about 15 minutes in this case. And this ensures that the system stays online for a minimum of 15 minutes. Second up, you have your maximum duration per day. And the maximum duration per day can be set, for example, to 60 minutes. And this is when you want to make sure that the load is not longer operated than these 16 minutes. So this would be the case, for example, for a pool pump. When you know the pool pump has an operation range of about 60 minutes, then you can set it in the maximum duration per day. The last possibility that you have with your checkbox is the desired duration. And per day, you have the desired duration of, for example, 360 minutes. So in this case, you can set up a desired duration and a finish time. So for example, in this case, we know the customer, for example, leaves the house in 6 a.m. in the morning and wants to have a fully charged electric vehicle in the morning. And therefore, we set the desired duration to 360 minutes, finished by 6 a.m. in the morning. So therefore, you can make sure that even, for example, if there is snow on the PV generator, that there is the load operated for a minimum time. Next possibility is then to have the energy management priorities. So in this case, you have the possibility to set priorities within your energy management. So you have the possibility to choose between battery, load management IOs, and OwnPilot. So depending on what is the highest priority, you can set battery to number 1, load management to number 2, for example, and the OwnPilot, the hot water generation, to number 3. And the system looks like that. So for example, if you set the PV battery to number 1, then first of all, the PV surplus energy is used to charge up the battery system. When there is surplus energy left, then the OwnPilot is activated and heats up a heating rod in a hot water boiler to generate your hot water in the system. And all the remaining energy is then sent to the electric charging solution and therefore charges up your electric vehicle. Of course, you can freely choose which priority is the highest. So for example, if you have an electric car in the system, you want, for example, to choose the charging solution to priority number 1, because when the customer plugs in his electric vehicle, then he wants to make sure that the electric vehicle is charged. All you need for this solution, again, is of course the Fronius GEN24 Plus device, a PV generator, of course, a battery storage system, and the Fronius smart meter at the feeding point. So therefore, I have brought you a practical example, and therefore we have our PV surplus energy curve, so our daily production curve, and there you see what happens during the day. First of all, at 7 o'clock in the morning, there is the battery charged. So first of all, the battery is being charged up to top. Then around 8 o'clock in the morning, the threshold for the pool pump for the first energy management output is activated. Therefore, the pool pump runs until the maximum duration has reached and then deactivates again at 11 o'clock. After that, the hot water is generated by the Fronius own pilot, so there is still PV surplus energy available, and this is used for generating hot water. After that, at around 2 o'clock in the afternoon, there is still surplus energy left. The hot water is already generated, the battery storage is full, and after that, we have still surplus energy left. And of course, we don't want to waste this surplus energy, we want to use it. And therefore, we have the possibility to do the practical example number 2. We just set on another load management output for charging up an electric vehicle. So now again, the battery is being charged and the pool pump is activated in the morning. And after that, when there is more surplus energy, the electric car is also being charged. So in this case, you can use the PV surplus energy for charging up your electric vehicle. After that, around 4 o'clock, the battery system is being full, and then the hot water generation is activated again by the Fronius own pilot, and the PV surplus energy is used for generating hot water. So in this case, we don't have to waste any energy into the public grid. We don't need to feed in energy into the grid, and we can use our PV energy for our own and therefore make a very attractive economic system with that. So this is then the full consumption of our sector integration with hot water, mobility, and electric loads. So last part for today is the installation and commissioning of our GEN24 Plus device. With our now new hybrid inverter, we have made sure that the installation and commissioning process is a very easy process. So in this case, you have the possibility to first lightweight wall bracket, and therefore you need 4 screws to install this lightweight wall bracket. After mounting the wall bracket, you can just easily snap in the inverter itself into the wall bracket and therefore mount it to the wall. After that, we have the fast locking screws. These are 180 degrees fast locking screws, and therefore we have 4 screws on the inverter itself to make available a very easy and fast installation process. For connecting the AC and DC cabling, we have our spring connection. So therefore, you don't need any torque or any screwdriver for installing AC and DC cabling. You just use our spring connection and therefore plug in the DC and AC cables, and you just spring down the spring connections and therefore have a good connection. So this is now the connection area of the GEN24 Plus. So in this case, on the left-hand side, you have the MPP1 and MPP2 Plus, as well as the plus of the battery output. On the right-hand side of that, you have the minus MPP1 and MPP2, and of course the minus for the battery. On the right-hand side of the inverter, we have the AC connection area. There you see your AC connection, in this case 3-phase, and we have our PV point. So the PV point is now a single-phase backup solution. So in the case the grid fails, we have the possibility to activate this PV point, and then you have a single-phase backup solution without external switches. On the left-hand side, then you have your PE connection for connecting protective earth. And then we have in the middle our data communication pilot. So this pilot is now available for all the data communication of the inverter itself. There you find, of course, your Modbus communication to the battery system, for example, and you also find your digital IOs for making your energy management available. So this is then the possibility for the data communication of the inverter. Okay, regarding the commissioning of the GEN24 Plus, we have the smartphone app available. So on the left-hand side, you see the logo of the Fronius Solar Start. And of course, you can still commission the inverter via the web browser, as we are used to from the Snap Inverter series. So in this case, you can connect to the Wi-Fi access point of the inverter and then just type in the IP address 192.168.250.181. And with this IP address, this is the same for all Fronius devices. You can connect to the web browser of the inverter. Of course, please feel free to use our smartphone app, our new Fronius Solar Start app, and especially for the GEN24 Plus devices, this is a very easy commissioning system. The app takes you by the hand, has some very fast and straightforward commissioning processes, and then you have finished the process of commissioning with the GEN24 Plus. So if you want to gain more further information about installation and commissioning of the products, please feel free to check out our Fronius homepage, fronius.com, and there you can find more information about installation and commissioning. Also on our YouTube channel, we have our how-to videos, and you can check them out on our website, how to commission and install our inverters. If you are interested in some training, we also deliver trainings to you. So for example, we have the battery storage system and energy management training. So if you're interested in such a training, please check out our website on fronius.com under the Solar Energy and Info Center and Events. Okay, so for the second part, I now want to ask my colleague Christoph if we had any questions during the webinar. Are there any open questions, Christoph?
Yeah, right now we haven't got any questions so far, Michael. My offer now again, so if you have any questions right now after this presentation of Michael, just send them through. So we will, of course, answer them. Other than that, I would say we turn off our microphones, we stay online for you if you have any questions left, and we'll answer them then via chat. And yeah, also one organizational answer I want to give you regarding the recording of the webinar. If you are interested in the recording, if you want to watch it one more time or hand it to your colleagues, we will send this out to your email address in the following days. Also, the presentation will follow, and you can then go through it one more time if you want. Yeah, and with that, I hand over back to you, Michael.
Thank you, Christoph, and I hope you enjoyed our webinar today. I hope you gained some new information about our GEN24 Plus device. And I want to invite you, of course, for joining our next webinars. Please make sure to subscribe and to check out our new webinars monthly. So for that, I say thank you for your participation today. We will stay online for you if you have any questions left. And I want to thank you and see you the next time here at Fronius. Take care and goodbye.